Welcome to NASA Science Live. This is your chance to interact with NASA experts and have your questions answered in real time. I'm your host, Tahira Allen. On today's episode, we're exploring NASA's historic endeavor to partner with American companies to deliver science and technology to the moon through the Commercial Lunar Payload Service Initiative, also known as CLPS. Now, on February 22nd, Intuitive Machines' Odysseus lander touched down on the lunar South Pole region, delivering NASA's science and technology to the surface. Odysseus continued to operate on the moon, collecting important data, taking photos, and deploying NASA instruments in advance of upcoming human missions to this same region. Let's get a better understanding of this new way to deliver science and technology to the moon.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
As you can see, all of this is in an effort to conduct science, test technologies, and demonstrate capabilities to help NASA explore many regions of the moon multiple times a year as we prepare for Artemis. Let's jump in to discuss what we've learned from the science that operated on the moon over this past week. Now, as a reminder, if you have questions throughout today's show, you can send them in using the hashtag AskNASA on social media or by dropping your questions directly into the comment stream wherever you're watching. Today, we are joined by two very special guests who are going to be answering those questions live on air. We have Dr. Sue Lederer, who is the project scientist for CLPS here at NASA. Welcome, Sue.
Very happy to be here with you.
And we have Deborah Needham, who is a program scientist for the agency's Science Mission Directorate. Hey, Deborah.
Hi, Tahira. Great to be here today.
Yeah, and thank you so much for being here with us. Now, to kick things off, titles at NASA can be a bit technical. Could you both go into a little bit of detail about your individual roles on the CLPS initiative? Sue, why don't we start with you?
Absolutely. As the NASA CLPS project scientist for this mission, I've been working with our payload teams, planning for operations during the years leading up to the mission. And ultimately, for the past 2 weeks, I sat on console in the NASA backroom at IM's Mission Control to help orchestrate our payload teams, both in transit to the moon as well as on the surface of the moon. So throughout this time, I worked alongside a full NASA ops team as well as with our payload teams. It's an exciting time.
Oh, can't wait to hear more about that too later on in the show. Deborah, what about you?
Yeah, thanks. So I'm kind of on the more programmatic side. So I helped create the opportunities for the instrument teams to propose and execute the amazing science investigations across the CLPS program. And I also worked with the selected science teams and technology teams to establish what it means for their investigations to be successful during this mission.
Well, this is really great. I mean, it is such an exciting time in space exploration. You know, over these past few weeks with the US's first soft landing on the moon in over 50 years. Now we have 6 NASA payloads on the lunar surface thanks to Odysseus's Intuitive Machines Odysseus lander. Sue, could you give us a quick summary of these 6 NASA experiments?
Absolutely. So we have sort of this common theme amongst the 6 payloads. The NASA payloads on IM-1 tested technologies that will help to pave the way for how to navigate to and land safely as well as autonomously on the lunar surface. They've also allowed us to investigate the environment that the NASA Artemis astronauts will experience and to help to develop technology that we need to live and work safely on the surface of the moon.
And so would you mind, so I understand there's 6 payloads that were delivered to the surface of the moon. Could you give us a quick, just high-level summary of what each of those 6 were?
Absolutely. So first, the payloads are all on board the IM-1 lunar lander that's formerly called Odysseus, but we like to call him Odie. So on Odie includes a number of different NASA instruments. The first is the Navigation Doppler LiDAR. It used lasers to help measure how fast and how close to the lander Odie was, or how close the lander Odie was to the surface of the moon as it landed. The IM-1 lander's navigation system was also designed to use some of the data generated by this instrument during its descent and landing, in addition to using another suite of navigation instruments that were installed by Intuitive Machines. The laser retroreflector array can reflect light emitted by an incoming or orbiting spacecraft right back at the spacecraft to give future spacecraft a reference point on the lunar surface. LRAs are also installed on other landers already on the moon and will be put on future landers with other NASA CLPS payloads. Next is the radio frequency mass gauge. This measured propellants and fuel in the tanks throughout the mission, from fueling the tanks before launch, throughout transiting to the moon under microgravity conditions, as well as during and after landing. Next is stereo cameras for lunar plume surface studies, whose goal was to image the engine exhaust plume as it churned up the dust on the lunar surface. Its secondary goal was to image the exposed fresh surface below the lander throughout the lunar day for science investigations. Wasn't able to collect data on descent this time, but we were able to test it in space as well as after landing to help prepare for its next mission, which will be on Firefly's Blue Ghost lander coming up later this year. The next payload is called Radio Wave Observations at the Lunar Surface of the Photoelectron Sheath. It's a payload that conducted radio astronomy both in transit to the moon as well as from the surface by detecting radio waves emitted by the currently radio quiet sun. It baselined how radio noisy the Earth is from the lunar surface, both at high frequencies and low. It took data designed to measure dust impacts to help us better prepare for the environment for future Artemis missions that will be exposed to this dust. And finally, Lunar Node 1 tested technologies that act like a lighthouse that guides a ship, but instead using radio waves that can help guide spaceships, serving as a beacon for autonomous navigation, kind of like how we use GPS on the Earth. And the LN-1 team didn't know it when we launched, but they played a big role in helping the IM-1 lander Odie navigate from the Earth to the moon. So that's our set of 6 NASA payloads carried to the moon by IM-1's mission and the lander we call Odie.
Wow, and I mean, just such cool, innovative technology. And so I understand, we've landed on the moon, the science is operational, we're receiving data back from it. Deborah, what happens next?
Yeah, that's a great question. So, for Intuitive Machines, for this delivery, the payload teams will continue to analyze the data that they've brought back and also archive the data that can be archived so that other science and technology teams can use that data for their own projects and to better understand the environment of the lunar surface going forward. But for CLPS, this is just one of the first deliveries demonstrating the concept for the commercial Lunar Payload Services. This is the second attempt and the first successful attempt to land on the surface of the moon. And for these initial CLPS missions, that is exactly what we were looking for, is establishing this as a capability for the agency and really for the world to take advantage of, to get better more frequent and more affordable access to the lunar surface. So going forward, we actually have 6 more deliveries that NASA has contracted with American companies. 2 more even just this year. It's an incredibly busy time for us for lunar science. But so 2 more later this year, and then 4 more going forward to deliver NASA science payloads to the lunar surface. So we're very excited about all the science opportunities that are coming up for CLPS.
Yeah, absolutely. And that this is just the beginning. And so I want to stick on this topic of CLPS, but kind of zoom out a little bit. Deborah, could you help put into context how CLPS is beneficial to NASA's Artemis campaign and building this sustained presence on the moon?
Yeah, absolutely. There are a couple different answers to that question, or let's say parts of the answers. So one is NASA and science in general have many outstanding science questions about the moon. Where did the moon come from? When did it form? How did it change over time? How did the activity on the lunar surface change over time? That require global access across the lunar surface. So CLPS offers that opportunity, and those science objectives are fed into the Artemis, but into NASA's Moon to Mars campaign. So looking at the moon to learn more about the moon, but also our place in the solar system. So going forward onto Mars as well. But for Artemis in particular, CLPS establishing this capability of access and delivery to the lunar surface has the potential to enable us to deliver science instruments or tools that the Artemis astronauts can use and deploy in the future during Artemis missions. So it can be a direct link between CLPS and Artemis and enabling and enhancing Artemis exploration going forward.
This is so cool to think about, right? The future of human exploration, lunar science. And so we have a lot of great questions coming in online from our viewers. So let's just jump right into this Q&A. As a reminder for those watching live, you can submit your questions for Deborah and Sue by using the hashtag AskNASA on social media, or by dropping your question directly into the comment stream wherever you're watching. All right, so our first question today is from the Scientific Potato on YouTube, who asks, do you believe that this technology will help us possibly get humans to Mars one day? Sue, why don't you take this one?
I absolutely believe that the technology that we're using for CLPS can apply to Mars. And in fact, we're having those discussions right now about how that potential can be used for the future. As we noted earlier, there's a lot of technologies that we are designing and developing and testing right now for CLPS that allow us to land safely on a planetary surface. And because they allow us to land on the moon, it also is technology that can be used for landing safely on Mars as well.
And Deborah, I know you're involved too in kind of the choosings of these science instruments. Is that something that that the agency keeps in mind when determining which instrument makes it on a lander?
Yeah, that's a great question. So for the moon, we do have there are fundamental questions that can only be addressed on the lunar surface. For example, so the moon's surface preserves the most ancient times of the solar system history, whereas Earth, for example, and Mars too, to an extent, has experienced drastic resurfacing. Wind, water, even running water early on Mars history has reshaped the surface. Although Mars does have ancient terrains, we look to the moon as the cornerstone for understanding the timing and the earliest environment of the lunar of the solar system environment during which planets generally were forming from the primordial soup of the solar nebula. So we do look to the moon in particular for learning about. We have specific science objectives at the moon that we're addressing with many of these investigations, but there are capabilities, exactly like Sue said, there are capabilities not only landing and descent technologies, but also scientific instruments and the technologies associated with those that can be applied to Mars as well.
And so, Sue, I actually have a great question for you. We have Pierce Relay on X who asks, does NASA see itself working with intuitive machines well into the future?
I can tell you that we already have 2 additional task orders. That's what we call them at NASA, but there's 2 more missions that Intuitive Machines is working on with us already in play. So we have IM-2, and that will take both a drill as well as a science instrument. It's called a mass spectrometer. The concept is that it actually sniffs the volatiles like water and methane and things that can easily evaporate, and tries to figure out whether or not we have any detection of water on the surface of the moon. We certainly have evidence that water exists there, and so we're bringing instruments to detect water to a number of different locations in the South Pole. And IM-2's mission is going to be one of the first that will allow us to do that. And then IM-3 is also already contracted with Intuitive Machines. They have a suite of what we call PRISM instruments. That's just one of the programs that NASA has that's designed to take instruments that aren't just built by NASA, but they're also built by other companies and as well as academia. So there's a number of different instruments that will be taken on the IM-3 lander as well. So we have rovers, we have hoppers, we have drills, we have instruments trying to sniff to figure out what's on the surface. There's all kinds of additional science, like Deborah was saying, that is very specific to the moon, and others that can be applied to other places like Mars for the future.
Okay, so we have a lot to look forward to. Deborah, we have Kamal Manzoon on YouTube who wants to know, when can we expect this next CLPS launch?
Oh, yeah, like Sue said, it's later this year. We actually have 2 more, one slated for fall and one slated for winter of this year. We're very much looking forward to getting those off the ground and onto the lunar surface.
Now, these CLPS launches, as y'all had mentioned earlier, are really laying the groundwork for future human missions to this exact same region. We have a question from Heidi Williams on YouTube who wants to know, when will humans go back to the moon? Sue?
Oh, gosh, that's a very good question. And the Artemis program is designed to bring us with humans back to the moon. And I actually think Deborah is probably the better person to answer what the current estimate is for when Artemis is expected to both orbit the Earth, kind of like Apollo 8 did, as well as to land on the surface.
Yeah, so the next Artemis dates are currently slated for late 2025 to orbit and 2026 to land. So that's the plan right now, that we're pushing forward to get humans back to the surface of the moon. We're so excited to get really having humans explore the surface is so important. Humans have, obviously cognitive capabilities. They can think in real time, make decisions for how they're going to select which samples, put that in context with the surrounding materials, and help us learn so much more in such a much shorter period of time that we can't wait to get them back to the surface. And
Deborah, why is...
Sorry, go ahead.
Why is this lunar South Pole region of such interest to NASA?
Yeah, so as Sue said, we have detailed data that we have taken from orbiting scientific instruments that point to the potential for water resources in the South Polar region. And those resources are important for enabling a sustained human presence for exploration on the lunar surface, but also pushing forward to exploring Mars. So as you're seeing on the screen, those blue areas are where we've pinpointed from orbital measurements where there's hydrogen and hydroxyl materials on the surface. And we have to learn how are those materials on the surface? Are they on top? on the very surface, or could we just scrape them up? Or do we have to drill down into the subsurface? Are they blocks of ice, or are they just part of the mineral grains, of parts of the rocks themselves that we have to really work to get them extracted so that we could process them and use them for exploration? So a lot of the missions that we're planning, like the IM2 analysis, are helping us understand how those volatiles, those materials, are situated in the surface and figure out how we can use those to help sustain presence. But those materials are in really challenging places to get to. They're locations that are permanently shadowed from the sun. So the sun never actually directly lights up those areas. And those areas are really hard to explore. I mean, the equipment that we usually bring requires sunlight to power it. So the great thing about the South Polar region is that those areas of permanently shadowed regions are really close to areas that have prolonged illumination. And they're high in elevation, so that the sun can, not constantly, but prolonged periods where the sun illuminates that surface, enabling us to power the equipment we need to access the permanently shadowed regions.
And so I want to actually take us back now to the science and technology that was delivered to the lunar surface. We have SKD, we have Alexandra552 on YouTube, who asks, what information were you most excited to obtain from the recent IM mission? Sue, sounds like a good one for you.
You know, it's funny. We have 6 NASA instruments, and I've been asked before, which is my favorite instrument. And to have a favorite instrument is kind of like to have a favorite child. You love them all, but you just love them differently. So for us, it's been exciting that we can do radio astronomy for the first time, both in transit as well as on the lunar surface. It's exciting that we can use the LN1, the Lunar Node 1, to help us really learn how to navigate to the moon and how to understand how to communicate back with the Earth. NDL, this navigation Doppler lidar, is so well suited to use laser technology that allows us to really pinpoint how high up and how fast we're going. And so that's been really fun. They've gotten a lot of really good information back from that payload as well. And these laser retroreflectors that can just kind of fit in the palm of your hand. They're cute little instruments, but they're really powerful to allow us to create this whole network of data that we can really create this, the pinpoint of where the landers are after they're on the surface. And then scalps, near and dear to all of our hearts, they have these stereo camera images that they're designed to take. And we're really looking forward to the Blue Ghost lander that's later this year that Firefly is launching, because we also have a scalps that's on, sorry, and I forget the full name. I know I'm supposed to be using the full name, but it's basically taking stereo camera images. And that should be really exciting for us to do some additional lunar science from the surface. So for me, it's very hard to choose a favorite. And in fact, with all of them, we are doing a little bit of science. We have some things that are purely tech demonstration, like the radio frequency mass gauge, where, I mean, when you're in a car and you have the fuel that's being pulled down, you can figure out how much gas you've got left. Well, if you're in microgravity and it all floats around, how do you figure out how much fuel and propellant you have left? So we had to figure out a different way to do that, and the radio frequency mass gauge allows us to do that. So they're all my favorites in different ways, because they're all doing technology and science in a little bit of a different way. So yeah, it's hard to say what the favorite is. They're all favorites.
Well, I actually have a great follow-up to that. We have SKD on YouTube who asks, do you think that this technology is going to allow us to space travel for a longer time now with more efficient energy power?
Yeah, I think that definitely it will. We have these, like, for instance, our Lunar Node 1 allows us to communicate back and forth between the spacecraft and the Earth. It allows us to do a better job at estimating what its orbit is and what its trajectory from the Earth to wherever we're going will be. So that's a really good one. And then again, this radio frequency mass gauge. How is it that you know how much fuel you have left? If you don't know that, how do you know how to really know if you can have a longer burn or a shorter burn? How is it that you're going to use your spacecraft to be able to navigate to the next place out? So we definitely have some capability for the longer term, just the initial early stages of that, but we're on our way there.
And so thinking about this longer term, right, we have Edward Wong on YouTube who wants to know, will NASA ever build a moon base? Deborah, you want to take that one?
Yeah, absolutely. That's the plan. That's what one interpretation of what a sustained human presence on the lunar surface means. And so NASA is actively planning what does a lunar base look like. But that's what the Artemis program is, or the Artemis initiative is aiming to do, is to accomplish that.
And so we have still me on YouTube who wants to know, why go back to the moon? Deborah?
Yeah, that's a great question. So if you think of lunar exploration think about it on Earth. If you went to the Sahara Desert and that was the only place you went to on the Earth, you would not know everything about how diverse the environments are on Earth and how the vast diversity of life that permeates from the bottom of the ocean to the tops of mountains and everything in between. So going someplace new on the lunar surface is critical for our understanding of the vast diversity of lunar geology and lunar history as well. The Apollo missions went to different areas. They definitely explored very different areas, but they were actually pretty concentrated on the lunar near side, near the equator. And going to the south polar region of the moon offers us an opportunity to explore a very different region, very different environment. That's part of what this Intuitive Machines mission was helping us understand, what the surface environment is like in a more polar location. And then how do you communicate when the Earth is so low on the horizon, like it is in the South Polar region? That introduces some really complex conditions for how do you communicate back home. So there are unique challenges, but there are also unique opportunities to investigating the South Polar region. And then you also look to some future CLPS missions that we have already on the books to go to the lunar far side. And there's a very different environment on the lunar far side as well that can give us insight into when the moon formed, how it formed, and what its internal structure is like. So lots of opportunities coming up.
Yeah, and it sounds like lots of data coming up. And so we have Chandra on X who wants to know, will any of this data that's collected from the payloads be available to the public? Sue?
It absolutely will. When NASA builds instruments that go to various different places in the solar system, the goal is always to make sure that that data becomes publicly available. So there's a place that's called the Planetary Data System. It's PDS for short. And this is where we take all of the science data and we archive it so that everybody can have access to that data in the future. So it's very exciting for us that we have a way to share this data outside of NASA with the rest of the public, with the other scientists that are out there, not just in the US, but abroad as well.
That is great to know. And so my next question, Sue or Deborah, one of y'all jump in, but this is a question that we're getting a lot from folks online. A lot of people seem concerned. So I'm going to ask it. It's from Low Consciousness on X, who says, first of all, huge congrats on this great accomplishment. And that, this time Odie seems to have tilted a bit on landing. And what are your thoughts on that? So, and they also follow up to say, am I correct in understanding that it did not have a negative impact on the mission?
So I can start with that, and then I'll let Deborah jump in. So it was really, for me, incredibly interesting to be part of the entire mission, to be in their mission control area throughout, from launch to landing and all the way until the very last moment that Odie was sending data back. So when you have a mission where it doesn't land completely upright, but it has a little bit of a tilt, it absolutely has an effect on how you communicate back. The thing to me that was really incredible was watching all of the people, all of the camaraderie, all of the collaboration that we had, that their team had, and how hard everybody worked to ensure that instead of having it lean over and then having that be mission end, instead we were able to operate all of our active payloads from the lunar surface. We have evidence now that even the laser retroreflector that's on the surface will be able to be seen from the Lunar Reconnaissance Orbiter called LRO, that's a spacecraft in orbit. So watching this all happening, the thing to remember that's really important, it's so hard to communicate. This is a really complex machine. It's the first time that it's ever flown in space. There are miles and miles of wire and cables and things that need to communicate, engines that have a brand new technology that's never been tested before. And so trying to get all of those pieces to work perfectly for the very, very first time that it has ever flown means that you allow for no allowance for things not to go right. And when you're too afraid that things are going to fail, it also means that you don't allow for these incredible successes to occur, to allow yourself to really face the challenges. And when you face the challenges, everybody works together. And so I saw people, gosh, they were working so many hours of the day. We had people sleeping in offices and laying on the couches because they didn't want to leave in case somebody needed to get their help. So we all pulled together as a community. And there were so many things that they, Odie would send back some data and we'd have to figure out how to fix it or how to work with the spacecraft to really, make some adjustments along the way. And all the people would get together and figure things, come back and say, we have a solution. And then something else would come back and we'd say, we have to think about that. And we'd all come together and come with another solution. And so the way to really innovate and make sure that something succeeds is to allow for those challenges to happen and then really come together to work through them. As a team, the IM team worked together, the IM team worked with NASA. So all of us, including the commercial payloads, did this incredible job where I felt like every time they came in and said, we have something that we need to work on, about the fifth, sixth time they came in, we all looked at each other and smiled and said, but we know that you know how to fix these things. You're just going to pull another rabbit out of the hat. And then the next time they'd come in, they'd say, okay, we have it resolved. We know what to do. So by allowing this really complex instrument to go through the whole life cycle of launching for the first time, transiting to the moon for the first time, and allowing for it to figure out to maybe not land perfectly, but then to use that new challenge to figure out how to communicate back to the Earth, it presented other kinds of data that we never expected to get back. So we had, for instance, one of our rules has 4 antennas, and we were supposed to deploy all of them at the same time on the surface, or one after another on the surface. Well, the sun decided that it wanted to deploy one of those before it even landed on the surface. But instead of the team being disappointed, they were excited because then they were able to collect data when we were in transit to the moon, different data that we didn't expect. And like Deborah was saying, when we got to the surface, because it was lying on its side, it allowed us to really dig into how do you communicate when the sun is so low on the horizon and the Earth is so low on the horizon that the data is kind of bouncing around on the surface as it comes back. Without that, we don't have as much data to really understand the challenges as well and to better prepare for even IM2 as well as for Artemis. So I know it's a very long-winded way of saying that things didn't happen exactly as we anticipated, but thank goodness for all of the additional data and knowledge that we gained, and really the team that bonded together in the process of all of that.
And what a story of just like perseverance and overcoming like ingenuity, everything. And so, Deborah, do you have anything to add to that?
Just one thing that I'd add is CLPS was always expected to be a risk-tolerant initiative. The idea is that usually space travel and exploration has been pretty much entirely in the hands of governments and government agencies across the world. That those government agencies tend to have a lot more resources than, or in this case, private companies. And one of the amazing feats of this, and one of the accomplishments of Intuitive Machines, they were the first entity to land on the surface of the moon, private company to land on the surface of the moon on their first try. That is an incredible success. Yes, as Sue said, it wasn't, straight up and down. It was like slightly tilted. And yes, that had implications for the mission, but they did that. And they operated our payloads, all of our powered payloads, on the surface and beamed data back. That is an incredible accomplishment. And as Sue said, they learned so much about how that spacecraft works that they're going to take all of those lessons learned and apply them to IM2. And they're also working with the other companies that are in the CLPS vendor pool, all of the vendors who are eligible for proposing to these task orders that Sue said, these deliveries, to help them with lessons learned. I mean, not proprietary technologies is going to be proprietary to the company, but they're learning lessons that they're sharing because they understand that we're establishing a lunar economy, and the success of one is the success of all. And so we're applying these lessons learned to the future. We're going to have other lessons that we're going to learn, right? I mean, this is a risk-tolerant endeavor. There will be other lessons to learn, but I really think that they learned how that spacecraft works, and we're really looking forward to IM2 to see how they applied their lessons learned to their own spacecraft. And we're also looking forward to Firefly's in delivery later this year to cheer them on as they learn their own lessons about their own spacecraft.
Yeah, and to remember that NASA also, when we were very, very early on, the first time when we were building Apollo and learning lessons, we had failures along the way as well that helped us to better prepare for our future missions, right? So expecting us to get things perfectly is like putting a child on a bike and expecting that they'll get it perfectly the first time and they'll never falter on their way. But allowing that to really, grow really helps us in the long term. So the fact that they got all the way to the moon and landed softly, we worked on the surface of the moon for a whole week is really, to me, just absolutely incredible. We didn't even do that with our first Apollo mission, right? Our first one, we just went around and came back, and then we tried landing later where they went all the way to landing on the surface for their first one. So it's very exciting.
It is exciting. And so Steve Graves on YouTube wants to know, with the success of Odysseus, does NASA expect to have regular moon missions on, say, a weekly basis, a monthly basis in the future? Deborah?
Yeah, that's so our plan, NASA's plan, is to have 2 deliveries a year. Now, obviously, this year we have a kind of a crunch period where we have 4 in 1 year. But the goal is to have 2. But what I'd say is NASA's goal is we don't want to be the only customer on these deliveries. The idea is that as we establish this lunar economy, that there will be other companies, other academic institutions, other countries that want to take advantage of this opportunity and many opportunities to go to the lunar surface. So really, as many as the customer base can support is what the eventual delivery cadence can be.
And so talking again about deliveries to the moon, NASA deliveries to the moon, we have a great question for you, Sue. It is from Matthew Henson on YouTube, who asks, what is Lunar Trailblazer and how does it work?
Oh my. So that's a great question. And it's actually not an instrument that's on one of my task orders. So I'm gonna hand that one over to Deborah. I know my own payloads very intimately, but not as many of the other ones on the other task orders. Deborah, can you step in?
Yeah, so Lunar Trailblazer is the next step for understanding the composition of the lunar surface. So it'll be an orbiting suite of instruments that's looking very specifically for where the water is in these polar permanently shattered regions in the South Pole, but also in the North Pole. So just kind of global distribution of those. And it's going to be delivered later this year is the plan to go. And so it'll be on a delivery to the lunar surface, and it will be dropped off in orbit while the lander goes to the surface. But yeah, we're really looking forward to having those measurements. They're supposed to be really high resolution, so we'll be able to see in fine detail where on the surface these volatile bearing deposits are.
And so it's a great follow-up to that. We have Julian on YouTube who wants to know, if there is water on the moon, will it be the same as Earth?
That's a great question. And the answer to that is yes. When you have water, right, it's two hydrogens and an oxygen connected together. And so water on the Earth is the same as water on the moon or on comets, or in fact, on other planetary systems as well. So this is really one of our drivers for going to the South Pole. A lot of people say, well, why are you going to the South Pole? It's very cold down there and it's hard to communicate. But what is one of the key elements for life to exist? And everybody who's ever gone to their faucet to fill up a glass of water knows that in order for life to exist, we definitely need a resource of water. So our goal is to build a permanent lunar base at the South Pole, or at least a lunar base that exists for a period of time at the South Pole. Those astronauts that are going there are going to need a source of water. And at least on the International Space Station, we have ways that we can take water and clean it up to allow the astronauts to drink and to live. And the more water that you can harvest from the moon and from these permanently shadowed areas that Deborah is talking about, the less we have to launch from the surface of the Earth. So it saves us all a lot of money as well. As mass that goes up and down, all of these things play a role in trying to make these decisions. But water itself is the same everywhere in the universe. It's a great question. Great question.
Yeah, actually, do you mind if I add to that?
Absolutely.
So Sue is absolutely right. Like water in its chemical form is the same throughout the solar system, even Earth, Moon, and comets and everything. Just like Sue said. One thing I'd add, so from an exploration point, Sue is spot on. From a science point, there's one other component to the questions that we're looking for in water, and that's looking specifically at the oxygen and hydrogen have different molecular weights. So you can look at the isotopes of oxygen and hydrogen and kind of get a picture for where they came from. And that's one of the real critical questions from a science perspective that we're looking to answer in the South Polar region is, where did that water come from? There are at least 3 different sources that we think of. There's the sun. The sun is peppering the entire solar system with hydrogen all the time. And that's a kind of, think of it as a renewable resource. It's peppering the surface of the moon with hydrogen, and that hydrogen can bond with loose oxygen on the surface and form hydroxyl and potentially water. There's also comets and asteroids. We know there's water on those bodies that could be delivered to the moon. And those carry a very different isotopic signature, kind of a thumbprint for the water and to tell us where it came from. Or it could come from inside the moon itself. In the early 2000s, some very intriguing scientific studies found that there was actually water that was sourced from inside the moon, and it erupted in volcanic eruptions on the lunar surface and released that water. And if it happened, if those eruptions were massive enough and fast enough, we could actually have become a pretty significant source for water, but that those eruptions were really old in lunar history. So understanding where that water, where those volatiles would have ended up, and whether whether the South Polar region acted as a sink for those volatiles, will help us understand where the water on the moon came from, and that, by extension, can also help us understand where water on Earth came from. So some really interesting science questions out there you have to answer.
Yeah, absolutely. And so I actually have a fun follow-up to that. So it's Trubano on X who wants to know, will we ever be able to drink moon water? And how much water is under the surface to get at? Deborah?
Yeah, I think that's a combination of, it is, isn't it? Right. So we also bring a limited, I had mentioned earlier, we bring a limited amount of water up to the International Space Station, and they have to figure out how to reclaim that water. So they have different ways to pull the water that's wastewater and turn it back into drinking water. So when we go to the surface of the moon, like Deborah was mentioning earlier, we are trying to learn with our CLPS missions, what kind of water is it? Are they in chunks of ice? Is it like intimately mixed where it's kind of like a dirty snowball? Like, how is it that it's mixed in? But either way, the goal is to create the technology that's necessary to be able to extract the water from the lunar soil in order to be able to drink that water from the surface of the moon. And just as another note, if anybody feels like they're now concerned that we're drinking moon water instead of Earth water, just remember that when the Earth and moon formed, they formed as this planetary body. So the kinds of water that are on the moon, we expect, are very, very similar to the kinds of water that we have here on the Earth. So we expect that not just expect, but from the investigations that we've done into the water that's in our own oceans, there's indication that water comes in part from comets and asteroids, as well as comes from the original nebula that the Earth and the moon formed from. So there's the same kinds of sources that would be the source of the water on the moon are the same sources that the Earth has had for its water that Deborah did a fantastic job overviewing. So hopefully that gives them a little bit of comfort, knowing that it'll be safe water once it's properly cleaned and taken from the moon.
Also very cool to think about that one day we will be drinking moon water. So,
right.
And so I know we've touched on this before, but for our viewers that are just tuning in, I want to ask it again. We have David Sanchez on YouTube who is wondering, will there ever be a crew to land on the moon again? Deborah.
Yes, absolutely. That is the plan. So NASA's Artemis initiative is working to get astronauts to the surface of the moon with a goal to study the South Polar region of the moon. And the reason that we've chosen the South Pole is because there are, like we've been talking about, resources potentially in the South Polar region that could prove very valuable for enabling a sustained lunar presence, a human lunar presence at the South Polar region. But also those resources are very close to areas of prolonged illumination. So the sun can power the hardware, the architecture that we need to support humans can be powered from the sun and these islands of prolonged light in the South Polar region. But yes, we're sending humans back to the moon, and we're very busy planning all the science investigations that they are going to achieve once they're there.
And CLPS, again, is a first step in this road to sustainable lunar presence on the moon. And we have Mansour Ahmed on Facebook who asks, what are the key scientific objectives from the new instruments that have been operating on the moon over the past week? Sue, would you mind summarizing that again?
Sure, absolutely. So this kind of overall picture that we're a very early mission. It's the very first one that Intuitive Machines has built and sent, and one of the first that we've contracted with commercial companies in order to go back to the moon. So the suite of instruments on the first intuitive machines lander were very carefully selected to try to help us to better understand how to navigate safely to the moon, how to land safely on the moon, how to communicate with your lander back to the moon, and how to look down and see how the dust gets churned up so that in the future, while we're designing spacecraft, that we have an understanding of what kind of dust and rocks and things like that might get kicked up by your lander. It will help us to better design future landers for the or that go down to the surface of the moon. But in addition, some of the instruments that allow us to study the dust, the stereo cameras for lunar plume surface studies and the radio wave observations at the lunar surface for the photoelectron sheet. These are designed to help us then also understand how does the dust come up as we land, but also how does the dust end up getting charged? Anybody who's walked around on carpet and kind of created a charge and then gone and hit something and it zapped their finger, right? So there's also this charging that can happen on the lunar surface from the sunlight that's coming in. And so the astronauts themselves are going to have dust that ends up clinging to their spacesuits. So how do we design spacesuits and how do we design instruments to help figure out how we deal with all of the lunar dust? So there's a lot of different things that we can do with these early instruments to help us better prepare, better design technologies, not just the technologies of the future instruments, but also spacesuits and how we're living and working in space.
And Deborah, how do we prioritize these questions that we are trying to answer with these selected investigations?
So NASA looks to the science community to help us understand what the science objectives are and what the priorities are. So NASA works with the National Academies of Science and Engineering and Medicine. And every decade, once every 10 years, we ask the academies to come up with the overarching priorities for science and for the Science Mission Directorate for planetary exploration. And so we at NASA look to the science community to help us establish those priorities. And then for the instruments that we're talking about for CLPS, we look and see, we ask the science community to propose instruments, and they are asked to link their investigations to those, what we call the decadal science priorities. But yeah, in the end, the whole mission is to further the knowledge that we have of how the moon formed, how the solar system evolved over time, and how all of that helps us understand where we come from on Earth as well. So it all turns back to science investigations and driven by priorities established by the science community.
And it's very cool too to see that this is, a global unified effort, that everybody has a voice in this. And so I have a final question for you both. What advice would you give to someone who is interested in joining NASA's efforts to return humans to the moon? Sue, why don't you go first?
Oh my goodness. It's such an incredible experience, right? To work with a lot of other people that are so driven by the science, by the technology, and even an understanding, especially understanding that there are challenges along the way. I mean, we talked last week in our press conference about how Odie, our lander, is this scrappy little dude where every time there's things that need to be worked on that we all work on together, and he always comes back and he really helps us to enable all of the science and all the technology. But the reality is that he enables the science and technology because of the teamwork, because people understand that it's a challenge. It's not something that's super simple. It's something you have to work really hard at, but the rewards are just incredible. Right here we are, and we have this lander that ran for a whole week on the surface of the moon and collected data on the way there for us in ways that have just been incredible to be part of as a team with the commercial industry, within Intuitive Machines, with NASA, with each of our payload teams. Our payload teams have worked tirelessly for years getting these payloads ready. And so it's just understanding that if that's the kind of challenge that you love, if that's the kind of incredible experience that you want to have, that's the kind of reward that you get. So my input to them is that throughout my career, this has really been one of the most incredible experiences that I've had. I also didn't get a lot of sleep over the last couple of weeks, but it was so worth it to work with all the teams and this great spacecraft. Deborah being one of them, but also our full CLPS operations team, IM, the payload teams. It's just been an incredible experience.
Thank you. And Deborah, what about any advice from you?
Yeah, absolutely. So I think, I grew up knowing that I wanted to be a scientist. I, took the classes and school and all of that. I always wanted to work for NASA. Like, this is a dream come true for me, to work with cultivating strategy, coming up with strategy and implementing opportunities for science. When I joined NASA, you always think of, science and engineering and all of, that's what I need to focus on to be a part of NASA. Joining NASA, that's just not true. There's so much beyond science and engineering that makes NASA what it is. It's there's artists, there's graphic designers, there's communications specialists, there's so many other aspects to the mission, to achieving mission success. So my advice is if NASA and space exploration is something that you're passionate about, that's great. You can find whatever interests you and apply it to that. And there's a place for you as part of NASA's mission. So find something that you're passionate about, and there's an opportunity for you at NASA.
Thank you so much for that great advice. As you mentioned, I do comms. Like you said, we've got mathematicians, we've got lawyers, everything. So there is a place for everybody at NASA, and that's really something incredible to remember. Unfortunately, this is all the time that we have for today, but Sue and Deborah, congratulations on the success of this incredible endeavor. And, thank you again for taking so many questions from our viewers online today.
I also want to say thank you to you and all the viewers. This has just been a real pleasure. And we hope that all the excitement and all of the work that we put into it really helps to inspire you, each of you individually, to become future space explorers.
And thank you so much for having us. This was a pleasure to answer your questions, and look forward to the next exciting mission down the line.
Yes, and thank you to everybody that joined us online today. It is always so much fun getting to just interact with you live, and we hope that you enjoyed learning more about the recent moon landing and all of the exciting NASA science that is in store. Now, if you would like to stay up to date on NASA's CLPS initiative and how it advances our Artemis missions, follow NASA Artemis on Facebook, X, and Instagram. There you'll receive updates about the program as well as operational milestones for active missions like the one that we talked about today. For the latest science from the moon, you can follow NASA Moon on Facebook and X and NASA Solar System on Instagram. Thank you all, and see you next time.
It's a new era.